last time we met. In regards to having your students driving forward the robot 800 millimeters exactly, you got 90% mastery. Good job on that. How did you do that?
We practiced. I gave them, all right, I want you to drive 20 millimeters. And they practiced 20 millimeters. Then, okay, I want you to practice 50 millimeters. 50, they practice. Okay, let's go in reverse. 1,000. They go back 1,000. All right, let's go forward. Okay. 800. And they were able to code using my example for the drivetrain.drive forward 20 millimeters. And I'm telling them, okay, all you have to do is change the parameters.
Look right now, we are looking at the robotics standard CSRB.Y1.5.3, which is evaluate the qualities of level appropriate student created and non-student created algorithms. So break that standard down for me. What does that mean?
Okay, so you are being evaluated on how well you can make an algorithm, which is a step-by-step set of instructions for the robot. At this point, it's a non-student created algorithm because the task was already given to them.
I see.
So if it was student created, then they would do it from scratch.
I see. I think that with that there, after breaking down the standard, let's now begin just trying to take a look at the actual code. You wrote the code yourself, right? What are the vital areas of the code that shows that students have mastered that non-student created algorithm? And you said we're focusing on picking up the water bottle and spinning it. So what parts of the code are we looking for in particular?
The claw underscore motor dot spin.
Claw underscore motor spin, where it says reverse? Okay.
And then wait 5 seconds. And then claw underscore motor spin forward.
Forward. So that's the spinning, right?
That's the to open and close the claw.
The open and close claw. Okay.
And then here where it says arm motor dot spin for, that's raising the arm. And then you drive, then you have to open the water bottle to drop the claw. So that's the spin reverse.
Spin reverse. So the spin reverse is
for the claw.
Can you read that code for me again?
Claw underscore motor dot spin
reverse.
Reverse.
And this drops it? Drops the water bottle. Got it.
Okay.
Let's spar. What is the difference between what I wrote in regards to no versus what you wrote in regards to no? Like, what would you take from my example? What would I take from yours?
Okay, so what I would take from yours is you gave the directions for the drivetrain with the blanks so that you could see if they could fill in those parameters. And you gave the code for to drop the water bottle to see if they knew where to go. And then here you gave the full example of what they needed to know for this portion to turn it.
And I determined, I felt from my viewpoint, I approached this from a literacy standpoint as someone who teaches the autobiography of Malcolm X, not creates machines that can pick up stuff like that. I felt that was the actual tier 3 vocabulary, the vocabulary they would not encounter outside of a robotics class.
Got it.
So the way I just thought about it, drivetrain, drive forward, they need to understand that this means they want the robot to move forward, and that these 3 blank spaces right here, the first variable is the direction, the second variable is the distance, and the last variable is the unit of measurement. So that would be a vocabulary block where if a kid saw that, like, okay, if I say drive_forward 8 cm, what does that mean? The robot's gonna go forward for 8 centimeters. So basically, it's more like an equation.
Got it.
Where they need to know they're gonna plug in the proper parameters and stuff. How is that different from what you put down for vocabulary?
It's different because in my thinking, I said, okay, they need to know how to convert from centimeters to millimeters. They need to know how to start a new program, set up a device, and open up the template. That's just the basic knowledge of getting into the coding arena. And they need to know that before they get into the actual performance task. And then I thought about here words that they may encounter as I am giving them instructions on things that they could potentially need, like programming. What is programming? What is interaction? What is solution? And so in my head, I was thinking I would want them to know this information before we got here to the actual interacting with the code program. And when I said pseudocode, they knew that I meant, okay, you need to create a fake code before you start your actual code.
And that would be one of the things I would take from your chart. Anything now in regards to the show portion?
I just gave them kind of like a cheat sheet that's on the board, but you actually gave the direction, like the things that they need, the parameters. You gave the parameters for the most productive struggle, and I was just thinking, okay, they need to know drivetrain.drive for what goes in it. But if I don't model that and I don't practice that, they're not going to know that there are 3 things, or there are things that go inside that parentheses that's constant.
Exactly. And that's why I just wanted to annotate right there for you. That this is the action where they pick up the bottle and spin it. And then based off your task, that's the most productive struggle. That this is the new content that they need to master. And therefore I need to model and make sure that as they're building up their programming fluency with Python, they commit these commands to memory. So they need to know, they should come in already knowing how to drop the water bottle, how to make the drivetrain move, how to make it turn. What's new for them is picking it up and putting it down. So this is the vocabulary that I need to teach and let them play around with. Let's go to the one that showed full mastery. So which kid are we looking at?
Iris.
Iris Pavel? All right. So just taking a look right here and then comparing it to your exemplar code. Reverse, forward 8 degrees. Forward 20 degrees. And these green hashtags right here, like green project code, pick a bottle, that's just saying what that particular code does, right?
It's just the organization piece.
Got it, the organization piece. So I think one thing I'm noticing from Aris, that's how you pronounce it?
Iris.
Aris? His or her?
Her.
Pronouncing her name. I'm trying to find the waits 5 seconds. Basically, that's the that's the portion of opening and closing the arm. Iris doesn't have that, right?
I'm trying to see where, let me look at mine, because I put on there, I thought I put on there somewhere that the weight was optional.
Mm-hmm.
If I didn't, I meant to.
But despite that, you're saying that Harris was able to pick up the water bottle.
Mm-hmm.
So where I'm looking for the code, claw spin reverse, claw spin forward, right?
Mm-hmm.
So that's the code that we're looking for. Claw spin forward, and then claw spin reverse. Because taking a look at your performance quiz, you don't have the 5-second thing.
Mm-hmm.
That's just something you did, right?
Right.
And Harris this is basically the part of the code that you were looking for.
Mm-hmm.
All right, cool. Let's now take a look at a kid who only mastered some of it. So who do you want to take a look at now? Jaden, Jonathan.
Those are all mastery. Then here,
Jesse.
Let's
take a look at what Jesse did. So drive chain, claw motor set position, drive forward, spin forward. So what he wrote here, he wrote spin for forward 280 degrees.
Mm-hmm.
And then taking a look at the second claw motor, he wrote claw motor spin forward reverse 280, claw motor spin forward 280. How does that compare to what you and Harris wrote?
Okay, so up here where he did the spin forward, he opened it, then he lifted the arm, and then here he closed it,
Mm-hmm.
and here he opened it again. So he did not pick up the water bottle.
Because we would just simply see a claw spin forward. So in other words, I think now if we're just going to stamp some of the misconceptions, right?
Mm-hmm.
And using the language of the no-show chart and stuff like that,
Mm-hmm.
let's just try to stamp this. For kids who are making a mistake here, what are they missing? Or what are they doing that's resulting in an error?
They don't realize or know the code for claw and arm.
So if we were to use the language of the vocabulary and stuff like that, there's a lack of mastery on claw underscore motor dot spin.
Mm-hmm.
And then the parameter as to what direction he needs to do it.
Okay, yes.
That typically speaking,
Mm-hmm.
what you and Harris did, in your various way, you were able to get that parameter string correctly
Mm-hmm.
in the sequence.
Mm-hmm.
And where we're seeing it, they're either unable to end the sequence
Mm-hmm.
or they do not know the code.
Right.
What do you think is closer, them not knowing the code or them not
Them not knowing the code, because Tremon didn't even choose the command properly.
Mhm.
He just typed in raise the arm,
Yeah. Raise the arm.
go down. Okay, right here he just typed in raise the arm 200 degrees.
Yeah. So he does not know the vocabulary.
Mm-mm. And that was what he saw on the performance quiz.
Got it.
He just copied it
And
right
then,
to the.
and then when you compare that to Jesse,
Mm-hmm.
he has a conceptual understanding.
Mhm.
He's just choosing the wrong code commands.
Mm-hmm.
Like you're choosing an inefficient code command.
Mhm.
It's actually not giving you what you want, and it's too complex.
Mm-hmm.
So if we were to stamp the misunderstanding, they need to have mastery of claw underscore motor dot spin.
Okay.
And they have to have mastery of that parameter. And the
Mhm.
order of the parameter is reverse and forward.
Mm-hmm.
All right. So now that we stamped that, okay, we're doing good. We have now. So we know that what we're reteaching right now is that claw spin, claw dot spin, forward, claw dot spin, claws underscore, sorry, coding is hard for me to speak. I'm not too familiar yet. Claw
Code
underscore motor dot spin, reverse, and forward.
Mhm.
Those are the two vocabulary concepts that we want to teach.
Okay.
So we have always two models of reteaching, modeling or discourse, or
Okay.
modeling or guided discourse. Given that we only have 26% mastery, modeling, you doing a complete reteach for the entire class
Okay.
would be the most effective way in which you would try to get this done. So pretend I'm a student.
Okay.
Like, talk to me like I'm a student.
Okay.
Like you're teaching.
So when we go into codv5.bex.com and we open our file, we need to make sure that we look at the commands on the side. And so the claw and the arm is going to be connected. You have to go to motion and you have to go to claw.spin and the parameter for the direction only at this time. We'll practice using the parameters later. So we're going to choose claw.spin and then your direction.
What I'm definitely would take away from yours is like actually downloading it into the robot and stuff. Like ultimately, again, this translates into movement. So therefore, we want to make sure that whatever code we're programming, the proof is going to be in the pudding right here. This isn't like ELA where it's like you have multiple interpretations of a book. The robot either did the thing or the robot did not do the thing. So this is how I would model, and I just want you to pay attention to how I would do it and what you would take from my practice.
Okay.
First, I would celebrate previous successes and review previous code. Hey guys, so we're going to come back to this task. We only had about 26% mastering, and in this class, we don't rest till we get 100% mastering in regards to our coding. What we did well was getting that robot to move in the direction we wanted to do. You guys are showing a lot of mastery of drivetrain.drive_forward and really setting those parameters and finding out the unit of measurement. Same thing with getting the robot to turn, and same thing getting the robot to move at a particular velocity. You guys are showing a lot of accuracy in regards to organizing your Python code like that and setting those right parameters. Where we struggled is, and this is number 2, introduce new vocabulary. Where we struggled was getting the robot to pick up the bottle. So what I would then put on the board is that vocabulary term. If you want the robot to simply pick a bottle up off the floor, the code for that is claw_motor.spin, and then you have a space for the parameter. Now for the parameter, if you want the robot to close its arms, you would write reverse, because the arms are always going to be open. So make sure that you have that, write that down. If you say reverse, what's the robot going to do? It's going to grab something. If you put forward in the parameter, what is that robot going to do? It's going to let go, drop what it's going to do. So we want to make sure that we have that memorized and that, we're going to get a cheat sheet, but in the week, you have to have that memorized. Because ultimately, if you want to work for an organization like Google, you have to have these parameters memorized, and you got to be able to code hundreds of lines there on the spot. People are going to want to be able to see how you code on the spot when you don't have a cheat sheet. So my first 2 things: review the previous code, celebrate successes, introduce vocabulary, and the vocabulary is claw_motor.spin parameter. Third, error analysis. Smart. What would you take from my practice?
What I would take from your practice is the successes, celebrating the successes, the error analysis, and then I want them to be able to, like you said, memorize the vocabulary, and then take time to talk about, give them a script or a prompt and have them to annotate it, and then compare with the people in their group, because that's going to help them see before they actually see the code if there was something that they needed to redo in their code. And then when I provide them the example or the exemplar, they would be able to say, okay, this is where I went wrong. So they have a starting point of where they went wrong. And that's why you see the organization of the code, so that, okay, my robot did this, my robot did this, my robot did not do this, so this is where I need to start. So that is what you're telling me is how I help them get the basic memory of the code, then be able to put it into practice. My first opportunity to reteach is tomorrow.
Tomorrow?
November 1st.
November 1st? What period?
I am going to reteach it all periods. So first, I teach all day.
Okay.
First, second, third, and fourth.
All day. All right. I will pop in
Okay.
and I will see how you do.